你因为那个我有开那个顶名对吗？然后它有时间，就有1-2分钟。如果你们来不及哦，然後沒了。對啊。Cái này có thời gian á, chỉ có 1-2 phút thôi. Nếu mà trong 1-2 phút đó mày không làm thì nó sẽ mất coi như là không điểm danh. Hả? Chỉ có 1-2 phút thôi, tao nói chỉ có 1-2 phút vô và điểm danh ngay.
就是说你点名的可以开10分钟吗？
这觉得只有3分钟而已。
最多3分钟吗
？3分钟。我看你一下可以改时间吗？等等。这个比较快，但是有时候有一点问题，很麻烦。但是这快下课要点名了，要爱你们很多时间。不行了，3分钟就。
anh chưa tắt máy quay à?
Kệ đi.
Hello. Let's see how this formula is true. Again, we use functional notation. Y equals cotangent, arccotangent x, equivalently cotangent cotangent x equals cotangent 1. But once x is given so many y's, if we restrict y to the first and the second quadrant, then there exists one and only one y. dy dx 1 over dx dy. Okay, by the derivative of cotangent is minus secant squared. Secant squared equals 1 plus cotangent squared. And the cotangent y is x. Thus, this one is also obtained. Or arcsecant. Okay, again we use functional notation. Put y, the dependent variable. This one is equivalent to secant x equals secant y, and y is in the first and the third quadrant. Because the space not too. Okay, so d dx arcsecant of x is dy dx. Here y is y and x satisfy this equation. Inverse function theorem I explained just now, reviewed just now. This is secant. The derivative of secant is secant tangent. Okay. And tangent here is non-negative because we choose y in the first and the third quadrant. Tangent x over y, x over y minus and minus is positive. So use the Pythagorean identity. Tangent equals secant squared minus 1. That's the reason why secant tangent is secant squared minus 1, then square root. Okay. Sometimes, if you know some properties of some function, then the corresponding properties we will have for the inverse of the original functions. For example, the laws of logarithms, and the inverse function of a log function is exponential functions. The corresponding properties are laws of exponents. Right? Got it? Yes. 所以说，一般来讲，给一个函数它有什么性质，它的反函数也会对应的有一些性质。例如说，对数 函数跟指数函数，对数函数有对数率，它的反函数是指数函数，就会有指数率。这两个都是同一回事，只是用不同的形式来表达而已这个也是。Okay, the last one. Use functional notation. You will learn in the maybe 7th or 8th grade. Cosecant. Functional notation. And this is equivalent to cosecant of y equals x. Cosecant. And we restrict the angle in the first and the third quadrant. First is the third is since cosecant is the reciprocal or 1 over sine y. Sine 0 is 0, so 0 should be kicked out. Now use differentials. Differential of y over differential of x if this function is 1, 1 and the differentiable and its inverse function is also differentiable. And with this relation, this formula. The rate of change of x with respect to y is the derivative of cosecant. Cosecant is minus cosecant cotangent. And in the third and the first quadrant, cotangent is non-negative. Non-negative. And then use the Pythagorean identity. Cotangent equals cosecant squared minus 1. So we have cosecant y is x times the square root of x squared minus 1. And this was also obtained. So, this is the so-called inverse trigonometric functions and their differentiation formulas. Okay. Their differentiation formulas. Easy to remember. It is easy to remember because the derivative sine is cosine, inverse is 1 over cosine. Cosine equals the square root of 1 minus sine squared. We know the derivative of cosine is minus sine. So inverse is minus sine, 1 over minus sine. And the sine equals 1 minus cosine squared. Tangent, whose derivative is secant squared? So inverse tangent, arctangent, whose derivative will be secant squared. The reciprocal of secant squared. Secant equals 1 plus tangent squared. And so on. Of course, you can ignore the explanation and just memorize all definitions, all formulas. According to my experience, my experience, right? Yes. Okay. This one is of importance. Is that yes, most important. I mean, this one is used frequently. as before, once we have a differentiation formula, we have some, it's, how to say, yes, general, somewhat generalized. If he is not x is a differentiable function of u, u prime, or same. And also, we have integral formula. And so on. So in the following, we will solve some, not all, maybe not all, examples in this section.